Hey guys, welcome to the first section on Jupiter. We're going to get an introduction to Jupiter today. What you're looking at there is just a stunning picture of the south pole of Jupiter taken by the Juno spacecraft. Juno's giving us pictures that are a little bit unique in two ways. The first is that Juno, because of the way its orbit is, comes very close to the cloud tops of Jupiter, at least closer than any other spacecraft ever has. The second thing that's interesting about Juno is it gives us pictures of the north and south pole of Jupiter, and we haven't gotten those up to this point. So that's a very sort of unique perspective in that picture. Jupiter is the very first gas giant. All the planets we've studied so far are terrestrial planets, meaning there is a solid surface that you could, in principle, stand on. That's not true for any of the other planets. Jupiter, Saturn, Uranus, and Neptune are covered in clouds. They don't have a solid surface you could stand on. There may be some point in the interior of the planet where it does become solid, but if you were to get anywhere close to that, you would be crushed. Jupiter and Saturn are called gas giants. They're made mostly of hydrogen and helium. Uranus and Neptune are often called ice giants. Their atmospheres are made mostly of water and ammonia ice. Jupiter is by far the most massive planet. This is a scale model. Here's Jupiter. Saturn is slightly smaller, although with its rings it's larger. Uranus and Neptune are still giant planets. And then there's Earth right down there. So you can Venus, Mars, Mercury. Did they put Pluto or maybe the moon? That's interesting. Anyway, you can see the terrestrial planets are all much, much smaller than the ice giants, which are in turn much, much smaller than the gas giants. Jupiter's mass makes up nearly 3/4 of the mass of the solar system, not including the Sun. Jupiter is the fifth planet from the Sun. Here we've got Mercury, Venus, Earth, Mars, and then there's Jupiter, Saturn, Uranus, and Neptune, and I think somebody put Pluto out there. Look at that. Let the revolution begin. Jupiter has rings. Turns out that all of the gas giants, ice giants have ring systems. Jupiter's aren't nearly as obvious as Saturn's. In fact, we didn't even know Jupiter had rings until I want to say the 70s or 80s when one of the Voyager is that right? One of the Voyager spacecraft turned around and as it was flying away from Jupiter took a backlit picture of the planet and somebody noticed these rings. Now this picture is not taken by Voyager. I believe this was taken by New Horizons. But Jupiter's rings are extremely faint. All of the gas and ice giants have extensive moon systems. Jupiter has 79 moons, but these are the four largest. Today we call them the Galilean moons, in honor of Galileo, who was the first person to discover them 410 years ago. This is Io. Io is remarkable because it's the most volcanic object in the solar system. This is Europa. Europa is remarkable because it has an under ice ocean, a subsurface ocean. Ganymede is remarkable because it's the largest moon in the solar system, larger than Mercury, and Callisto. Jupiter's been named for the Roman king of the gods, or king of thunder. Here's a bust of Jupiter, and this is kind of an interesting picture. This is taken from Pompeii. If I understand this correctly, those are the original colors, unless it's been restored somehow, but I suppose it was covered by fine ash and that preserved it. Jupiter and Saturn have almost the same composition as the Sun. They are 75% hydrogen, 24% helium with small bits of other things. But if you look at the cross section of Jupiter, it's kind of interesting. So at 60 miles, you would feel 12 times atmospheric pressure. That's about what you'd feel, 330 feet underwater on Earth. 370 miles beneath the cloud tops, you'd feel 1,000 bars of pressure. That's 1,000 times atmospheric pressure. And then even deeper, you'd feel 5,000. But so the pressure increases dramatically as you go deeper and deeper into Jupiter's atmosphere. And eventually, all of that hydrogen gas gets compressed under tremendous pressure to make liquid hydrogen. The liquid hydrogen then gets compressed to make metallic hydrogen. I'm not sure if that's quite solid yet. And then the core is a bit of a mystery. All of this is guesswork based on modeling, but the core is extra guessy, you might say. And then the final thing in our introduction to Jupiter is that because it does not have a solid surface, because it's made of gas, it's not very spherical. The fact that it's spinning pretty fast, I want to say it takes about 10 hours, for example, for the Great Red Spot to complete one orbit of Jupiter. I'm going to have to look that up again, but 10 hours sticks in my head. Because it's rotating so fast, it actually flattens a bit. And the difference between the east-west diameter and the north-south diameter works out to be, I don't know, almost a whole Earth diameter, right? And so the line you can see here is, of course, a perfect circle, and Jupiter's been superimposed on that. And there are gaps at the South Pole and the North Pole because Jupiter is flattened. And if you look at a picture of Jupiter, it's not too hard to convince yourself that you can actually see the flattening. That's unusual. All planets flatten, but for most of them, it's not quite as much as it is on Jupiter.